Good morning, students. Today I will take the class related to vitamins. As you know, we have already initiated the topic of vitamins, wherein we have covered various parts of vitamins, especially the the nutrition, the nutritional value, and the daily requirements, the concept of dietary reference intakes, and we have spoken about the fat soluble vitamins, and we have spoken about the water soluble vitamins. We further discussed about the roles of vitamins in promoting health, wherein we have discussed about the vitamin absorption and storage. We have covered both the fat soluble vitamin and the water soluble vitamin digestion and absorption. We have discussed and what parts of the intestine and these vitamins gets absorbed, and also to which system they go. So this slide shows that the both are absorbed in small intestine, and the water soluble vitamins get into the blood, whereas the fat soluble vitamins get into the lymphatic system. The fat soluble vitamins can be stored for a long period of time, whereas the water soluble vitamin have to be taken on daily basis. So we have also covered about the bioavailability, the destruction of vitamins, and the toxicities and overconsumption of vitamins, and the concept related to provitamins and preformed vitamins. We initiated the topic of vitamin A, and we have shown that how the vitamin A is being a very good antioxidant due to the presence of a lot of double bonds in its structure, and we have also studied that the importance of this vitamin in terms of the vision, wherein about 500,000 people worldwide are affected due to the night blindness. So we have also spoken about the discovery, wherein two independent groups in 1913, the McCollum and Davis, and the second group Osborn and Mendel, how they discovered the two factors in cod liver oil, wherein one component was easily inactivated by heat in the presence of air, which we call as vitamin A, whereas the other component was stable, and this was vitamin D. So the vitamin A, we discussed that it composed of three different biologically active molecules: the retinol, which has an alcohol group, the retinal, and the retinoic acid, which has the carboxylic group. So this is the structures of all trans retinol, the 11 cis retinol, and the beta carotene. So also the beta carotene, it consists of two molecules of retinol which are linked at their aldehyde ends, which we can see here, and thereby they are referred to as provitamin form of vitamin A. So most of the ingested beta carotene is cleaved in the intestine by beta carotene dioxygenase to yield the retinol. So functions also we discussed earlier, and I would like to give a very short recap of it. So we spoke about in the vision, the rod cells of the retina contains the pigment rhodopsin, which is nothing but 11 cis retinol, which is bound to opsin. Whereas when the light falls on this rhodopsin, it dissociates or it bleaches, and it gives rise to all trans retinal and opsin, two separate components, and this reaction is accompanied by conformational changes in this protein opsin, wherein it induces the calcium flux, which in turn triggers the nerve impulse and allows the light to be perceived by the brain, wherein we can see an image. So all trans retinol is incompletely converted to 11 cis retinol, and we need, for the constant supply of 11 cis retinol for rhodopsin formation, all trans retinol is really required in the diet. We discussed in detail the structure of retina and the eye, wherein we have seen the various parts of the eye, and we spoke about that retina is the innermost layer of the eyeball, and this has layers of pigmented cells which are layers of rods and cones which have photoreceptors, and there are also the bilayers, the bipolar cells, and the layer of ganglion cells. So herein we have an optic nerve wherein it goes to the brain and you can perceive the image. So we have also discussed upon exposure to light. So what are the changes which takes place? So upon light stimulation of rhodopsin, it leads to activation of G proteins, which is called transducin, and this further activates the G protein, and which in turn activates the cyclic GMP phosphodiesterase, which is nothing but PDE. And this PDE hydrolyzes the cyclic GMP and it reduces its concentration, and thereby it opens the sodium channels. Further, so due to this, there can be so this figure shows how the changes in the cyclic GMP level. For example, if the cyclic GMP is high upon exposure to light, so this can have impact on the membrane potential, and wherein in the dark they are depolarized, and so there is a tonic release of the neurotransmitters into the bipolar neurons. Whereas on the other side, upon the exposure to light, the activated retinal and the opsin, we said it gets bleached and it activates the protein transducin, which decreases the cyclic GMP, and the sodium channel closes, and thereby the membrane hyperpolarizes, and this hyperpolarization leads to the neurotransmitter release and which decreases in proportion to the amount of light. So there are various important functions which are important for proper development of epithelial cells and differentiation of these epithelial cells. The vitamin A serves as very important component of these. It supports the growth. It is essential for the activity of the epiphyseal cartilage, and also it is very important. Vitamin A is important and it has important role to play in the fertility, especially the spermatogenesis is arrested in animals in the absence of vitamin A. And the major sources here, and you can see the major sources are the cords and the cod liver oils, the shark oils, and the halibut oils. So the beta carotene is high in green vegetables such as spinach, the yellow vegetables such as carrots, tomatoes, and pumpkins, and the yellow fruits such as papaya and mangoes. So the cod liver oil, which I showed earlier, so it contains about 600 micrograms per teaspoon, and the shark liver oil contains about 300 microgram of vitamin A per teaspoon. So 1 microgram of retinol is equivalent to 3.33 international units, and normal requirement for men is about 1000 micrograms, for women is about 800 micrograms per day, and during pregnancy and lactation there is an additional requirement of 300 to 350 microgram. So vitamin A is metabolized mainly it is ingested in the beta carotene as a beta carotene or retinol, and the intestinal mucosa splits this carotene to retinol and is incorporated into the chylomicrons, and wherein it reaches the liver via the lymph and the blood. There is a limit on convertibility of beta carotene to retinol. So further, The excess of vitamin A, if you take a lot of vitamin A, it is stored in the liver as fatty acid esters, and these esters are stable, more stable than the alcohols. And the protein, retinol binding protein, is very important. And then further, they are secreted from the liver to the plasma. So the retinol and the retinol binding protein complex forms 1:1 complex with the prealbumin in the plasma, and this complex transports the vitamin A to the target tissues where a receptor on the cell surface mediates its uptake and is transported in the cell by cellular RBP. So this can be measured, the vitamin A can be measured using a colorimetric assay using antimony trichloride in a chloroform solution, where this color can be read at 620 nanometers. So this is vitamin A is very stable by normal cooking, but it can be destroyed for prolonged periods if it is exposed to air or heat drying. So the deficiency is not common in the Western countries, but it may occur in children with cystic fibrosis and or malnutrition, or in alcoholic conditions. So it can be treated with intake of about 30,000 international units of vitamin A orally. So there are various deficiencies which are associated with vitamin A. So the vitamin A levels below 20 microgram per 100 ml of serum indicates its inadequate content in the body. So the epithelial cells cannot differentiate in its absence, and the mucous membranes becomes very rough and dry, which may cause low resistance for microbial invasion, and the skin also becomes dry, and this condition is called xeroderma, wherein there is a scaly skin. It also leads to, its deficiency can lead to urinary tract infections, and a tendency for stone formation have been able to be ascribed to vitamin A deficiency. You can see here there is a scaly skin, and so the skin has a problem, as well as the eyes. You can see the blurred vision. So there is no tears in the eyes, which we call it xerophthalmia, and the poor tooth formation can also be noticed. So night blindness is one of the major conditions which is encountered due to the deficiency of vitamin A, and this is very common in the developing nations. And the night blindness is the difficulty of the eyes to adjust to the dim light. Especially the individuals are unable to distinguish between the images in low levels of illumination, and the people with night blindness have poor vision in darkness. But in the normal light, they can see normally. So the xerophthalmia, which is a medical condition, is seen in case in which the eye fails to produce the tears. You can see here the dry eyes, and which may lead to the conjunctival dryness and damage, and the complete blindness can also occur due to the vitamin A deficiency, because this has a major role in phototransduction, which we have seen in the earlier slides. So the phototransduction, as I described before, is a process by which the light is converted to the electrical signals in the cells of the retina of the eye. The other conditions are xerosis cornea. So that means the dryness of this eye can spread to the cornea, and it can lead to the keratinization of the epithelial cells of the cornea. Keratomalacia is a condition when the xerosis of the cornea and the conjunctiva is not treated, and it may develop to a condition called keratomalacia, which means degeneration of the corneal epithelium, and it produces opacities, and the cornea becomes more vascularized. You can see here the vascularization, and more edema, which means bulging, and the accumulation of water, and infiltrated with leukocytes. So you can see the redness of the eye. They have a lot of the blood cells, and this leads to the destruction of the cornea, and finally leading to blindness. Xerophthalmia is extreme dryness and keratinization, and the cloudiness of the eyeball, particularly in infants and the youngs. The vitamin A deficiency also diminishes the ability to fight to infections, and even the subclinical deficiency may lead to many other problems such as developing respiratory and diarrheal infections. They may have decreased growth rate, slow bone development, and they have problems with probability of survival from serious illness becomes less. And so, in addition to the dietary problems, there are other causes of vitamin A deficiency. Iron deficiency can also affect the vitamin A uptake. Excess consumption of alcohol can deplete the vitamin A content, and the stress level may also be more susceptible to vitamin A toxicity. The hypervitaminosis of vitamin A refers to either excessive intake of vitamin A, and this may occur and wherein the maximum limit of the liver stores of retinoids is exceeded, and this will enter into the circulation and causing the systemic toxicities. So the retinoids, these are the class of the chemical compounds that are related to vitamin A, and they are sometimes used as medicines, primarily because they are able to regulate the epithelial cell growth. And they have also roles in cell proliferation and differentiation, bone tissue growth, and the immune function, and they are involved in activation of tumor suppressor genes. So due to the hypervitaminosis, there can be symptoms due to the toxicity such as nausea, vomiting, headache, dizziness, blurred vision, and loss of muscular coordination. So the hypervitaminosis vitamin A can also lead to angular cheilitis, which is inflammation in the lesions in the lips are cracked, and there are splits, and this may also lead to bleeding problems. So the angular